Ladies and gentlemen, can you all hear me?
Yes.
Is it excruciatingly painful or is it okay?
I'm so sorry, sir.
Well, it's only going to get worse. I'm Chip Smith, and I want to welcome you to the 2026 Community Creek Talk here at the Murrells Inlet Community Center. We have a really interesting program tonight that's going to focus on two environmental things that are happening in Murrells Inlet and around Murrells Inlet that should be of interest to all of us who live here or use the inlet and appreciate it. First, I'd like to say that the Creek Talks began as chowder talks, and when you have chowder, you get about 150 people. We've got water fountains, so we are the dedicated core. But we started these chowder talks, which became Creek Talks, at the year of the second spring tide cleanup of Murrells Inlet. And spring tide is something that started here in 1992. This year will be the 34th iteration of spring tide, and that's on Sunday. It starts at 10 in the morning on Sunday down at the Morse Landing right by the Hot Fish Club, where we have an opening ceremony at 10, and we ring a bell for each of the departed that we've lost in the last year who were in some way associated closely to the creek and often with spring tide. We have a little music to send you off. We have the award of the Volunteer of the Year and the Golden Oyster Award from Murrells Inlet 2020. It starts the day with a good note. And then if we have enough people, and we generally have several hundred people, which is enough, then we get out on the water and on the streets of Murrells Inlet and pick up everything that doesn't belong there, and we can get that done in about an hour and a half, amazingly. And in the past several years, volunteers have also participated, if they wish, with a really interesting program that Kelly Thorvaldson is going to talk to us about briefly at the end of the program. It's called Our Marsh Counts, and the idea there is that you go out in teams and not only collect the trash and litter, and if you're out in the creek, the marine litter and debris that you find, but you also catalog it, and they compile this data so they know exactly how much of what there is. And we're talking about dedicated people counting cigarette butts. So it's not just picking the place clean, it's knowing exactly what you came up with. That's a wonderful program. Tonight I'd like to thank Beth Goodall and the Georgetown County Parks and Rec Department for the use of this building. Tanya Hodge, the excellent manager of the community center here, always a gracious hostess. Marsh Dean in the back is a videographer. And we're not going to do a whole lot of stunts and that kind of thing, at least in the beginning of the program, but he's ready should that happen. And Kelly Thorvaldson has come from, Kelly, do you live in Charleston?
I do.
Okay. Kelly works with South Carolina Aquarium, and it was our fortune in Murrells Inlet to be chosen by her as a community to be represented and to be, I guess, a test case in Our Marsh Counts, and she's going to tell us a little bit about that a little bit later on. I would be very remiss if I did not thank, and I do not see, Sandra Bundy over here. Sandra, although she prefers to be behind the scenes, she set up the date for this Creek Talk to coincide with spring tide, and she lit a fire under yours truly. And so we are here tonight with some very distinguished and informative guests. I'd like to thank everybody that set out the chairs, and please don't leave until we put them back. And I'd like, Chelsea, if you would stand up. This is Chelsea Murray, ladies and gentlemen.
Hi, everyone.
Chelsea started working with Stacy Blair Johnson at Murrells Inlet 2020 as a part-time worker, a part-time executive assistant in 2024, and she's now a full-time executive assistant and the social media manager. And Stacy delegated Chelsea this year to take a leading role in spring tide, and she has, and she's done a terrific job. very little help from me. And we're looking forward to a great day on Sunday, and I want you to give Chelsea a hand. She's doing a great job. And most of all, I'd like to thank all of you and all of those who do love the Inlet as much as the rest of us but aren't here tonight. It's our job to tell them what we learn. All of you are, as Sandra would say, connected to the creek, and you care about its health and its future. That's why we're here. I was fooling around on the typewriter earlier, just writing out little slogans, and I came up with one that I think applies to what we're trying to do here. If you care, you learn. If you learn, you care. Inlet traditions to share. So let's get to our program. Our first guest is Dr. Dennis Allen. Y'all can probably hear me fine anyway, can't you?
Yeah.
Okay. This is Dr. Dennis Allen, Distinguished Research Professor Emeritus in the University of South Carolina. Dennis was the director of the Baruch Marine Field Laboratory at Hobcaw Barony from 1978 through 2018, and he was the manager of the North Inlet Winyah Bay National Estuarine, and that, if you've never said that word aloud, you can read it 1,000 times and still be stumped. National Estuarine Reserve from 1992 through 2011. Also the past president of the Estuarine, you know what I'm saying, Research Federation. It's an international organization of estuarine scientists, managers, and educators. Dr. Allen's long career in research has centered broadly on the structure and function of salt marsh estuaries, that's easier to say, and their role as nurseries for fishes, shrimps, and crabs, and more specifically on the changes in the ecology, life cycles, and behavior of estuarine zooplankton and fishes in a changing world. Now we're going to talk tonight about the massive dredging project that has been proposed for Murrells Inlet, a project that would dredge 16.5 miles of inlet creeks, some of which were originally dredged, some of which were not originally dredged. And I wish that that y'all could have been with Dennis and I on his boat.
Chip, could I ask you to use the mic, please?
Sure, Keith.
It's on. You just turned it off.
It was off, you cut it off.
Electronically challenged.
Yeah.
There it is.
How about now?
Okay.
Okay.
Perfect.
On Monday, Dennis and I took a circumnavigation of the inlet in his boat, and for a couple hours, 2.5 hours, we went everywhere from out of the mouth where Oaks Creek is very nearly closed by a sandy shoal. We went from there down Alston Creek and got to a point where we could go no farther. We turned around and went back out by the mouth and then went all the way down Main Creek and all the way down the Garden Teddy Boat Canal, which obviously was a dredged creek. We turned and went up along the Atlantic Avenue Causeway, made our way back south, and looked into Mount Gilead and a couple of the smaller creeks along the way. And all in all, and Dennis had broken the dredging charts down so that at each creek, he could be very specific about what it was we were seeing. It was, for me, an incredible tutorial, probably from one of the most distinguished estuarine scientists in the world. And I wish y'all could have been there. Much of what I learned on that trip, y'all are going to learn tonight in this conversation between Dennis and me. Dennis, you want to try that microphone to see if it works for you?
Sure will. Dennis.
Well, let's begin with defining what an estuary is, how one is structured, and how it functions.
Yeah, thanks, Chip, a lot for the invitation to share some of my observations and thoughts and concerns and recommendations as they relate to this proposed dredging project. It's a big one and it deserves a lot of attention. What's an estuary? Well, I could take hours to do that, but let me just take 2 or 3 minutes. There are a lot of different types of estuaries, and those are classified pretty much by the amount of fresh water they receive. So they're river-dominated estuaries, Winnebago Bay and Cape Fear, but there are a lot of estuaries like Murrells Inlet, and we generally refer to them as high salinity salt marsh estuaries. And of course, the water in the creeks of Murrells Inlet are quite salty due to the twice-a-day exchange of waters with the coastal ocean. It shares the characteristics of most other salt marsh creeks being dominated by intertidal marsh and having a complex network of tidal creeks. The creeks near the inlet tend to be wider, deeper, sandier, and the interior creeks are quite different, of course. Lower energy, the tidal current's not as strong, enable sediments in the water to fall to the bottom and accumulate, and of course there is where we find shallower and muddy waters. We all recognize the key habitats of estuaries like this: salt marsh, mud flats, oyster reefs, sandbars. And one thing to keep in mind about salt marsh estuaries is that they're among the most productive ecosystems on Earth. That is, the rate at which they synthesize organic materials, both the plants and the algae associated with the system, the rate at which they can create all of this material often exceeds some of our best attempts at agriculture. And the plant production, of course, supports a high diversity and abundance and biomass of animals throughout the system. One thing we often refer to in estuaries is its function as a critical nursery. And this means that it provides lots of food and shelter for a really vast number, hundreds of different kinds of shrimps and fishes and crabs. The innermost section of the estuary, the one closest to the uplands, really is where much, if not most, of that action occurs. That is, we can think of about what state and federal regulations term that they use, and that's that these shallow marsh areas and creeks constitute essential fish habitat.
Has there ever, that you're aware of, Dennis, been a dredging project of the scope of the one that's planned for a marsh, the size and sort of shares characteristics with Murrells Inlet that you're aware of?
This project seeks to dredge almost every waterway outside of the federally maintained channel between the inner harbor and the ocean. And in doing so, it wants to cut into about 16.5 miles of creeks. That means it's going to be creating about 105 acres of new creek bottom. In addition to the dredge cuts, slopes have to be created on each side of the channel. And when you factor that in, the applicant identifies some 438 acres of essential fish habitat being impacted. In total, some 750,000 cubic yards of material would need to be removed. No matter how you look at it, this is a very large project. And I've tried to learn more about what else has been done in the history of South Carolina, at least during the permitting era, going back 50 years or so. And I can't find anything that really comes close to what's proposed for Murrells Inlet. Of course, the dredging of canals and both basins and tidal creeks has occurred in South Carolina for several decades. And dredging has occurred in more recent years at Hilton Head and up at Cherry Grove. These were pretty big projects, but the Murrells Inlet project would be about 3 times as large as each of those.
What in general, Dennis, are the effects of dredging these salt marsh waterways?
Yeah, there are a lot of generally stated impacts or effects. One of the big ones, of course, is the actual removal of habitat. We'll be talking more about that. There's increased turbidity, and alteration of the current and sedimentation patterns within the creek network. Decreased flushing usually occurs when you go deeper, and degradation of water quality is also associated with that.
And the projects that you mentioned at either Hilton Head or Devereux or places that you're familiar with, how did those in Cherry Grove, how did those projects turn out for those marshes?
You know, I'm most familiar with the one that was conducted in the northern reaches of North Inlet Estuary, about 15 miles south of here. In the 1990s, the Devereux community applied for permits to dredge about 3 miles of canals, and these had been constructed in the 1970s and had silted in. They also wanted to include in that project about 1/4 mile of naturalized intertidal creek, shallow subtidal creek, I should say, in order to connect it to some deeper waters in North Inlet. When it was done, about 40,000 cubic yards of material was removed. That makes it about 1/20th the size of what we're talking about here at Murrells Inlet. After years of legal challenges to the original permit, and the scope of dredging was actually reduced quite a bit. Depths and widths of the channel cuts were lessened. There were wider buffer zones required between the edge of the activity and the natural stretches of marsh and oyster. A proposal to cut a canal through the marsh was denied, and no dredging was allowed in the blind end canals that had become naturalized. With this scaled down operation, really relatively little shallow water habitat was destroyed, and no water quality issues have come up since then.
So that's a fairly good example of what you might call responsible dredging, although it sounds like it was kind of compelled by legal action.
Yeah, that's
What would you give us, Dennis, as the criteria for what constitutes safe dredging in terms of the
Hey,
depths?
Jeff, your mic is still off.
It's still off?
I
I don't know, maybe my battery's dying. How about now?
Yeah.
Okay. What I'm asking is for Dennis to talk about the criteria for what we might call safe dredging in terms of channel depths, channel widths, and how those are arrived at, and the channel profiles.
Yeah, well, my understanding is that there are not really any regulatory limits or guidance with respect to those criteria. Typically, the applicant states in its application what it wants to do, and the permitting agencies decide whether that's acceptable or not. Encroachment into intertidal areas outside, the targeted deeper channels that they want to create is generally discouraged by permitting agencies. So accordingly, the target depths of channels need to be scaled to the width of the existing creeks. That is to make sure that the dredging does not encroach into the intertidal, and that the slopes that are created are not too steep, because if they are much more readily eroded by tidal currents and boat wakes, creating sloughing that not only puts stuff back in the channel, but encourages stuff outside the original permitted zone to move in that direction. So there's a delicate balance between depth and the angles of the slopes that go up to the natural areas. After studying the cross-sectional diagrams for this particular project, I'm a bit concerned that a lot of them are not very well scaled to the structure and configuration of the existing waterways. Another risk with dredging deeper is the possibility of creating stagnation. So these environments are very rich in organic material, and the microbial communities break down that material, and in doing so consume a lot of oxygen. And if bottom waters aren't circulated enough during the course of a tidal cycle, and those waters can very well become lower in oxygen, and that can be very problematic for both the animals that live in sediment at the bottom as well as things that live in the water column. And of course, you've heard about worst case scenarios where the oxygen goes down and we have fish kills. Creeks that don't retain any water at low tide, of course, don't have any potential for stagnation. If you have a foot or two of water, there's generally enough turnover and flushing so that the risk is pretty low. What we're concerned about here is that the proposed dredging depth targets are 6 or 7 feet below mean low water in creeks right up along the edge here. And these are in waterways that are presently 0 to 4 feet deep at low tide. And the concern, of course, is that this could set up for some low oxygen conditions that would stress animals for sure. A safer dredging target then would be lower depths, that is reduced target depths would be the way to say it, in the western half of the network. And this would both reduce the potential for degradation of the water quality and at the same time preserve more essential fish habitat than the present plan would seem to seek to do.
If I could just follow up just briefly on that, Dennis. This project has been broadly represented to us as a means by which the water flow through Murrells Inlet will be improved. And the inlet will overall benefit from that. And from what I understand, what you're saying about the deepening of the channels in the smaller creeks, particularly, the flushing, rather than being enhanced as it's been represented, would actually be restricted, possibly curtailed.
Yeah, I mean, there are exceptions to all these rules, of course, but I think the general is that the shallower it is, the more of the water that's in there at high tide that leaves, the lower the risk of water quality problems developing. And, you know, there's this happy balance of where that maximum depth should be. 6 or 7 feet doesn't sound so good to me. 3 or 4 is more reasonable. And you know, we just have to see.
You've referred several times to the,
Again, broken.
you've referred, it comes on, it goes, how about now?
Yeah, good.
You've returned, and now it's not.
It says they're fully charged.
How about now? Now it's working. Let it stop again.
I think you're hitting the button.
No, I'm, it's on and then it goes right off.
They're brand new, so if they're not working, we're gonna send them back.
Can you hear me on this one?
Yeah.
Okay, but I'm just asking Dennis a follow-up question. And that is that he's referred several times to the intertidal zone as being particularly crucial to the life of the marsh. And I'd like to hear a little bit more about that zone, for example, what lives there and what is it that draws the life there and makes it such an important part of the marsh.
Okay, the intertidal zone, it comes as no surprise, is basically that area between the highest high tides and the lowest low tides. It's the most biologically rich and ecologically productive part of a salt marsh estuary like Murrells Inlet. Spartina, or the salt marsh cordgrass that we see out there, occupies the upper level of the intertidal. And the largest portion of what lies below is mostly mudflat and oyster beds. These flats support really high densities of animals that actually live in the sediment. And every handful of muddy bottom, pluff mud, contains hundreds, if not thousands, of these microscopic animals. And these muds also support higher densities of large invertebrates, ones that are more familiar, like worms and clams and burrowing crustaceans. But the important thing here is that that's a level of the food chain that provides for the next level up. And directly or indirectly, crabs and shrimps and fishes and birds rely at some point in their life cycles on these benthic animals. You might mention recently, there was a release of young flounder by the DNR into Murrells Inlet. Well, the number of those flounders that will reach adulthood in the coming years are very much going to reflect the quantity and quality of the shallow water habitat that's available to them.
So what would be the biological consequence of removing, diminishing, or disrupting this marginal intertidal zone?
Well, I think the removal of every square yard of shallow bottom means a reduction in the food available for larger animals. And the biggest consequence of removing oyster reefs and mud flats and marsh grass is a reduction in the capacity of the estuary to function as a nursery.
Which is one of the things that makes it most advantageous to those of us who live around it, is that nursery function. Are there advantages or benefits to be had through dredging such as this project?
Well, nobody can predict exactly how or how much the system's going to change. I'm really pretty hard pressed to identify any important advantages or benefits to the ecology of the estuary that would result from this. A fisherman might suggest that wider and deeper creeks would provide more space for larger animals like sea trout and red drum and flounders. That may be true. But what we have to think about is that reductions in the amount of shallow water habitat that the juvenile stages of those same animals rely on could, in the long run, mean that there's simply going to be fewer larger fishes produced in the system. Also, it's kind of interesting to think that deepened creeks could also encourage the increased access by larger predators. We talk about bottlenose dolphins and sharks, and they like to eat the same things we do. So in my opinion, the loss of shallow water habitat and the creation of creeks that do not flush these completely as the ones we see out there now pose a real risk. And I think the risk is knocking the system down a notch to a lower level of functionality and productivity.
Well, looking at this plan, how might it be revised to make the so-called unsafe or the narrowest and shallowest creeks safe for dredging, or should the narrowest, shallowest creeks simply not be dredged?
Should mention that we spent some time on the water studying the creekscape, if you will, around low tide, and I've studied lots of aerial and satellite images, trying to get a sense of how close the lay of the land matches, the intent of the applicant, it's hard to make these measurements, but I think that their estimate of 438 acres of stuff that would just be removed is probably a large underestimate. Some of the intertidal removed, to be removed is along bare waterways, where channels don't need to be as wide, the slopes don't need to extend as far, and as long as the boundaries of the permitted dredging activity are marked, the amount of damage is going to be reduced. But when you get back into, the western side of the system, you find much shallower creeks, much narrower creeks, as we mentioned before, and you also see these blind-end canals. And a lot of the mud and moisture and marsh that they want to remove is associated with those waterways. Some of them, and these are sort of creeks that extend into the uplands. Some of those are natural creeks. They're probably never very navigable at low tide. Others were probably almost certainly cut decades ago, but without being disturbed for many years now, they become naturalized and look a lot like so many of the other creeks in the system. So the safest option, I think, for the well-being of the estuaries is not to disturb these shallowest finger canals. Interestingly, another thing we can offer as a reason not to disturb these kinds of places is that our research in North Inlet has consistently shown that that the early stages of fishes and shrimps, particularly those that come in from ocean spawning grounds, tend to seek and reside in creeks most closely associated with the fringes of the estuary, with the uplands. Why, we don't know. Maybe friend Denise can help us with this, but it could be that they detect the freshwater signal and maybe stuff that's in that water responding to it.
Sea level continues to rise, Dennis, and we're told that these marshes, these salt marshes, will eventually migrate landward or become lagoons, open water lagoons, rather than salt marshes. Could you speak briefly to these processes, specifically what's required for a marsh like Murrells Inlet to accommodate itself, to adjust itself to rising sea level?
Yeah, salt marshes on the Atlantic and Gulf Coast of the United States are being affected by sea level rise. Spartina lives within a relatively narrow zone at the top of the intertidal. And in order to keep up with sea level, marshes have to trap enough of the suspended sediment in the water and accumulate it so that the platform keeps up with this constantly rising sea level. If they can't, these plants die after a period of time of being inundated for too long during tidal cycles, and they eventually drown. So what happens to dead marshes is they become highly perched mudflats, and of course they're more susceptible to erosion by wind and waves than when the marsh was growing there. And the trajectory for this is to become more of an open water lagoon. Now, decades of research in North Inlet and lots of other places up and down the coast have shown that Spartina marshes are losing the battle to keep up with sea level rise. Marsh estuaries like Murrells Inlet and North Inlet are destined to become dominated by open water rather than in seas of grass, if you will, in the coming decades. Some of the sediment that these marshes need to keep up originates from what comes from the uplands. Some of it comes from the ocean, but much of it is from resuspended materials within the core of the estuary as tides go across these muddy areas. Dredging operation increases turbidity, and it could very well be that during the project, extra amounts of sediment in the water will end up on the marsh and help build that platform. But in the long run, the removal of such large volumes of this shallow water muddy habitat could result in less material being available to get resuspended and deposited up there. In estuaries with undeveloped watersheds, over periods of tens and hundreds of years, salt marshes migrate into the uplands. And that process compensates for losses of marsh due to sea level rise down in the core of the system. But with mostly armored shorelines here in Murrells Inlet, we might expect this estuary to steadily lose salt marsh acreage, and with it would go some of the buffering capacity that the marsh provides during storms.
And that's something that we can expect to happen regardless of this dredging project. It's just a consequence of sea level rise.
Correct.
Okay. How are the oyster beds and oyster reefs in Murrells Inlet likely to be affected by the proposed dredging?
Yeah, well, oysters are often considered ecological engineers. The structures they create are really hotspots of biological activities. Oysters themselves are food for a wide range of estuarine predators, including snails and fishes and crabs and birds. Clustered oysters attract small invertebrates and provide refuge for things like amphipods and small crabs, fishes, and shrimps. And another quality of oysters, another service they provide is as filtering animals, they can improve water quality. Oysters can't survive in areas where there's a lot of sedimentation. They get buried, they die. Nor can they live in areas where there's so much suspended sediment that they can't filter enough digestible particles from the water. And that helps explain why we don't see many oysters in deep water here. The eastern oyster occurs from Canada down to Florida, and in the middle Atlantic reaches, where so many of the oysters we eat come from, the oysters live almost exclusively subtidally, below low water, and in fact sometimes in tens of feet of water. That doesn't happen here. Subtidal oysters are rare, and that's probably because the creek bottoms tend to be muddy, and because there is a lot of different kinds of things that eat them down in the creek bottoms. Also, oysters that do make it through those challenges for the first year or so tend to be occupied by boring sponges. They grow in their shells, and through their life create a problem for the oysters by perforating the shell, and that ultimately facilitates the death of the oyster. So few oysters reach adulthood here in subtidal areas. And it's one of the reasons that oyster culture in South Carolina is pretty much confined to floating rafts, particularly in the southern part of the state. We all recognize the importance of taking care of oysters for our recreational and commercial harvests, but the ecological roles that they play are critical and are often underestimated. I believe that the rearrangement of tidal flow in the inner estuary that might result from this dredging operation will damage some oyster beds. At the same time, it could benefit others. We don't know, we can't predict this. That is just how the replumbing of the creek network will affect their health and abundance and distribution.
If the benefits of this project should turn out to be detrimental to the marsh in some of the ways that you've mentioned, would they be reversible? I mean, could the marsh recover eventually on its own? And if so, how many human generations might that require?
Yeah, I think the simple question to the answer to the question, can the effects be reversed, is no. Once changes of this magnitude take place, Murrells Inlet will be a different place. It'll be a different kind of estuary. The proposed dredging will reset the way water moves around the creek network, and that will force changes in the chemistry and the biology of the system. Ecosystems like estuaries are resilient. They can, in a sense, adjust and repair some of the damages caused by disturbances. Major disturbances, destabilize systems more, but even there's a tendency to reestablish a more steady state in the years and decades that follow. We've seen this happen after major hurricanes have done physical damage to our local estuaries. So in a sense, some degree of recovery can be expected. The big question is just how different a system will result once that new state of stability is approached. Will the quantity and quality of habitats following the dredging project be as productive in terms of the nursery function? Will water quality degrade into deepened waterways close to the watersheds?
I mean, the whole thing strikes me in a major way as a mass experiment that's going to be undertaken on Murrells Inlet with a lot of possible detrimental effects, probable detrimental effects, and we just have to stay and see what happens. In terms of the dredge spoil, Dennis, they're proposing mass filling to a depth of 5.5 feet, an area just beyond the South Jetty off Huntington Beach that measures 5,000 feet by 3,000 feet, all of this dredge spoil would be pumped through pipes, some of which would have to be several miles in length to reach the so-called inshore spoil site. The plan calls for this nearshore disposal site to be monitored for thickness and movement, but doesn't say anything about what happens if they do notice that it is indeed moving. Briefly, what are your major concerns about the spoil disposal aspects of this plan?
Yeah. So what we're talking about here is outside the inlet, where all this material is going to be dumped essentially. The volume that's going to be generated is absolutely huge. I did a couple of quick calculations, and my recalculation here will surprise Chip too, because it's even bigger than I first thought. But this 750,000 cubic yards of sediment would result in the equivalent of a 23-story building on a 2-acre lot, which is about what the parking lot associated with the community boat landing here is. It's a big parking lot, and 23 stories is a long way up. But another way to look at it actually is that this volume would fill something on the order of 200,000 pickup trucks. It's a lot of stuff, and it's largely mud, and it's going to be dumped as a watery slurry from these pipes. It's just hard to imagine that they can create, a plateau up to 5.5 feet high over 344 acres of sandy, flat bottom, and that most of it could be expected to stay there. Ocean disposal has worked in some places. It's quite manageable, but I'm not sure that the conditions here are very favorable to doing that. And some of the things we have to consider is the very fine content particles that are associated with this material. Also, the site is very close to the inlet. In fact, we're talking about less than a half a mile from the jetty or from the beachfront at Huntington Beach State Park. And that raises a concern because major storms in this area are known to create bottom currents strong enough to bury or even displace materials that are used to build artificial reefs in much deeper water, much further offshore. So the likelihood of it staying there seems pretty slim to me. this leaves us thinking that, there just has to be a better way to deal with this material than build a plateau just off the beach.
You like the skyscrapers better?
I'm not sure about it, right? Between the adverse effects, that we're talking about inside the creek and this major disturbance outside the inlet, I really worry that the important role that this estuary plays in helping to nourish the coastal zone, with the next closest major inlets being 50 miles apart, I'm afraid that this would diminish that service that it's providing to support our fisheries and more out there.
In closing, Dennis, it seems to me that while clearly there are places in Murrells Inlet where some dredging is required, in the better traveled creeks, some of them have become unnavigable at low tide and spot dredging, I guess you would say. But that the scope of this project taken as a whole, given what you told us, is really pretty daunting. In closing, is there anything that you would add in terms of making this or any dredging project less detrimental to the life of the marsh?
Well, I mentioned some of these things in answering some of the other questions, but first and foremost, a reduction in the scope, especially in the depths of dredging, is very important. 6 or 7 feet in areas that are probably functioning pretty well as 0 to 4 feet just is imposing more risk than I think we want to on this estuary. We talked about how in the major creeks, those slopes have to be gentle, but it's really important, and this work Will and Debbie do, is to require that the dredge operator, working with regulatory agencies, actually put in PVC stakes that mark the edge of the dredge canal and the upper end of the slopes, so that dredge operator knows exactly where and where not to go. Because once those areas are flooded, you don't know where those edges, where those oyster beds are. So that would be an important thing to do. Slopes should terminate no closer than 15 feet from some of these living habitats. One consideration you hadn't mentioned is that as the dredge moves along the creek, the pipelines move with it and shift, and they can move into the intertidal zone. And actually, we saw this happen at Everdue, where pipelines moved and settled on oyster beds, pressing them into the mud, making them go away. Accordingly, it's most important that the pipelines are secured in the channel 24/7 throughout the projects. And one final thing I'll mention is that it seems important that a scaled down project be limited to a single year. Right now, we're talking about splitting this into 3 consecutive winters. And the rebalancing of water movement and the physical and chemical and biological attributes of the system in response to each of those disturbances, is going to be interrupted by the next one and the next one. And this could very well delay the system being able to achieve some sort of better balance, some sort of more stable state, if you will, by a number of years.
Well, folks, our object tonight is not to give you in black and white the answer to whether there should be dredging and to what extent in the inlet, but to leave you with the questions that all of us and the wider community need to be aware of as this project is pushed forward. I'd like to thank Dennis for providing us with a lot of those questions and a lot of, I think, those answers. Thank you so much, Dennis, for your effort in helping us with this, and for the wonderful education you've given me over the past week. It's been great.
Well, thank you, Chip. And thanks, everybody, for listening.
Can I ask a question, Chip?
Sure.
He talked about safe dredging. you talked about scaling, you talked about the depth. Who came up with that? And who came up with the disposal site? What agency or what entity did that?
Yeah, I don't know names, I've not talked to these folks. The application was made by Georgetown County, but they obviously had hired consultants, engineers, people who design projects like this. They're the ones that came up with it, and they provided it to the permitting agencies, the Corps of Engineers, and their various consulting agencies, including South Carolina DNR, the Department of Environmental Services, and that process of evaluation is ongoing. My understanding is these agencies have a lot of these very same concerns and have asked for clarification on points from the consultants, and they're waiting for those studies, the engineering studies and modeling to be shared.
Hey, Chip, first of all, Dr. Allen, thank you so much for coming and explaining in terms that we can all understand a very complicated, issue. And doing it with scientific facts and data and your experience. It's so valuable to all of us. I've got, I guess, two questions. It seems like this whole project, as far as the data, is in its shroud of secrecy, and you can't find any documents, any studies, anything. I asked, the county approved $800,000 for additional studies, and we can't even find out what those studies are about. They wanted a FOIA request.
Well,
So why is there not a website where documents are provided?
Well, I know what the studies that they just authorized are by a geotech firm in Charleston. I think it's called GEL. And I talked to their supervising engineer at one point. And he was a good guy, and he said, look, I'm very well aware that if this turns out to be a disaster, that's the end of my career. And,
It should be public information.
well, what they're working on now are some of the questions that Dennis raised about this. The one big question about this that everybody's looking at, including this firm, is whether or not that spoil site is really tenable or a terrible mistake. And they're performing studies and tests that they say are going to take about 8 or 9 months. And until those are done, they can't submit their permit applications to the permitting agencies, who I think are skeptical of many of the things that Dennis has.
Which leads me to my second question. Who has approval? Who has the final word in looking at all these studies and saying, we approve it or we don't? Because honestly, you can't count on any South Carolina agency, DNR, DES, because they get funding from our, legislature. And we've seen in this very room where they won't even speak about issues because our legislators, are there. So is it the U.S. Fish and Wildlife, or who is going to have the final say that this makes sense or this is going to be terribly damaging to not only our beaches, but, the biodiversity in our inlet?
Right. I don't know the answer to that as to, whether any one agency has veto power over the whole thing. I know it's got to be approved by the Army Corps. I think it's got to be approved by some part of DNR. I don't know the answer to that question, but it's multiple permitting agencies. I do know that.
The Corps of Engineers, I understand, has lead on these things. The Corps of Engineers has the lead on the permit, but they work closely, especially with the Department of, whatever it's called now, what used to be DHEC.
OCRM.
Yeah, there's changed.
Department of Environmental Services now.
But the state's permit has to do with water quality. The overarching interest of the project is more the Corps' responsibility. Is that, do you guys know any better? Denise?
I'm wondering how much of this whole dredging thing is pushed by, the people that are lobbying, you know, politicians for the boating industry. Obviously, you know, Murrells Inlet is becoming less and less navigable. And you don't have to be smart to drive around and see thousands of boats being stored in these places. And as far as I know, there's only like 2 or 3 places where you could actually put a boat in the inlet, you know? So I wonder why, you know, aside from the fact that environmentally I'm concerned about the whole thing, all right? But on the other side, if we don't do anything, eventually, you know, the whole inlet could be silted in. I studied turbidity going into the inlet, right, as part of my water monitoring team. And, you know, we've got all this, you know, construction going on everywhere, and more of that silt and that gets run off is going into the inlet eventually, right? So there's 2 sides to look at it, you know? What happens if we don't do anything? What's going to be the fate of the inlet, you know?
Well, these, not to interrupt, Bob, but these are the kinds of questions that all of us have to deal with in the course of this. But, you know, and there's a lot of ways to look at this. From the perspective of many of the people who live in a waterfront home on a creek, they want all-tide access out to the jetties. That's understandable, but you've got to look at the whole consequences of the thing to the marsh at the same time. But, and we're not going to get any ending on this tonight. And so again, let's give Dennis a big hand for helping us so much. Thank you, Dennis.
Thank you, sir.
And now we're going to invite Dr. Denise Sanger and Dr. Fred Holland up, and we're going to talk briefly about watershed science and the inlet. Denise, she's a senior marine scientist at the South Carolina Department of Natural Resources Marine Resources Research Institute, and she leads the Ecosystem Research Team and is the research coordinator for the Ace Basin National Estuarine Research Reserve. She earned her PhD in marine science from the University of South Carolina, where she fell in love with South Carolina's salt marshes and tidal creeks, and applied science with experience in coastal estuarine ecology and coastal zone management. Dr. Sanger has long worked with Dr. Fred Holland to improve our understanding of the impacts of urbanization on these vital and sensitive brackish and saltwater habitats. Dr. Fred Holland earned a PhD in marine science from the University of South Carolina in 1974, characterizing the ecology of intertidal habitats in the North Inlet estuary. In his 50-plus years of professional life, Dr. Holland focused his research on discovering and defining the linkages between coastal development and estuarine health. Most recently, his interests have been defining how changes in land use, particularly the conversion of formerly forested habitat into impervious surfaces, impact tidal creek habitats. Throughout his career, Dr. Holland has tried to convert his research findings into reliable information that can be used to make sound, enlightened, and informed environmental management decisions. So we welcome you two, Fred and Denise. Thank you so much for coming up from Charleston today. And let's get right to it. If you would, tell us exactly what is a watershed and how is the extent of the Murrells Inlet watershed defined or delineated?
I'm gonna need that. I'm gonna need that. You can hear me, can't you?
No,
No.
you need a mic.
Okay, good evening, everyone. I don't like microphones either, so I apologize, but I'll try. So watersheds, right? It is essentially, they can be multiple different sizes, and so they go from really big, if you think about the watershed for Winyah Bay, right? It goes all the way into North Carolina. But even within that system, there are smaller watersheds, right? Where a particular creek branches off, or a river branches off. And so watersheds come in lots of different sizes, For Murrells Inlet, right, it's very sort of self-contained, right? It's dominated by the ocean, and the watershed is, at least the the Hub 12, excuse me, which is a USGS designation, is around 10,000 acres. And so the importance of the watershed is anything that falls in that area will end up in Murrells Inlet in this case, or the receiving water body. So, a lot of times you think, oh, well, I don't live on the creek. Well, it doesn't matter, because if you live in its watershed, whatever rain that falls and whatever pollutants that are on the ground will end up running off into a receiving water body.
I guess I look at a watershed as the bathtub. Anything that falls in the bathtub goes in an outlet. A watershed of a tidal creek that is the outlet, the land, and all the hydrology, the hydrology and the groundwater that occurs inside that bathtub. That's a tidal creek. For tidal creeks, and tidal creeks like we have here, only occur between about Cape Fear and the Georgia-Florida border. That's the tidal creeks we have here. They have a 3 to 4 foot to 5 foot to 6 foot to 9 foot tide when you get down to Georgia. You got about, what, 4.5 foot here, Dennis? So, I mean, it varies all the way to 9 foot. Those creeks only occur between about Wilmington and Florida. But a creek's not necessarily a creek, and a watershed is not necessarily a watershed. Every watershed generally has multiple drainage basins. There are little streams that break off of it. And in the case of tidal creeks like you have in Murrells Inlet, they're all what people would call intermittent freshwater systems. They only have fresh water flowing in them some of the time, mostly after rainfall. Some of them might be continuous, but most of them are intermittent. So the watershed is where the action is occurring that's going to affect what occurs in the creek.
Tell us why and how its watershed is significant to the estuary. In other words, what functions does the watershed perform? Does it provide nutrients essential to the life of the marsh? Does it filter out or absorb harmful contaminants from rainfall runoff? Why do we hear that pervious surfaces in the watershed are preferable to impervious surfaces?
Yeah.
Well, the size and area of the watershed is important. The bigger the watershed, the higher the volume of rain that can run off from it. The soil type is important. If it's sandy soils, lots of it sinks in. If it's muddy or hard or rock or impervious, it runs off. If the slope is steep, the runoff is fast, and you have a problem with erosion. If the slope is gentle, like in the low country, it's fairly slow. It comes in slow. But you have vegetation types. If it's vegetated, got trees, lots of transpiration, the roots take up water from the rain, put it back in the air, so that's different. But if it's grass, or if it's poorly vegetated, it's a real problem. How many humans live on it? What's the human population density? That's an important attribute of a watershed. And of course, the degree of imperviousness.
Sure, your roofs, roads, and parking lots.
Yes.
Right? So any surface that the water can't actually penetrate into.
Want to say any more?
And so in a very natural system, right, where the water, when it falls within a watershed, yeah, it's going to percolate into the ground, right, because most of the surfaces are undeveloped. And any contaminants that it might pick up as it moves towards a receiving water body are generally going to be lower because there aren't significant inputs of them. In comparison to a developed watershed where you have lots of impervious surfaces, and Murrells Inlet overall for the 12, I calculated for 2021 is about 24% impervious surface already. The water will hit that impervious surface and it'll start running off right away into our receiving water bodies. And as it travels, it's going to pick up pollutants. And so that might be fecal coliforms from pets. It can be polycyclic aromatic hydrocarbons, which are fossil fuels, right? We all drive our cars. to other types of pollutants like nutrients, right? If you fertilize your lawn at the wrong time and you end up with a large rain event, that can also run off into a receiving water body. So the more chance it has to get in the ground, the better off we all are, right? From both a volume perspective, in terms of fresh water, but also the concentration perspective, that pollutant that's coming with it.
For those of you who got the little book, page 10 gives you the whole story about imperviousness. I guess one other comment I might want to make is you have to sort of remember that in our I guess a creek is not, all creeks aren't equal. Just like all people aren't equal, or all things aren't equal. They're what I would call headwater creeks. They're intertidal creeks. They're creeks that go dry or mostly dry at low tide. And those creeks are really important as nurseries. They have immense biological things happen there in terms of productivity, but a lot of geochemistry occurs there. A lot of things are converted, transformed, and I guess a lot of activity in terms that you don't see. Then there's a creek that has 1 or 2 feet of water in them at low tide, but at high tide there's 6 feet of water. That creek has slightly different functions. It works slightly different. I call those second order creeks. I call that intertidal creek a first order creek. And then it drains about 50% of the water that's in that creek drains at low tide in general, a second order creek. And then there's a creek which is larger. It's only about 20% or 25% of the water drains at low tide. I call those third order creeks. And they're big creeks, they're deeper, they have lots of different activities and functions in terms of flushing, etc. And they're occupied by different kinds and types of organisms. The important thing to remember though, some creeks don't drain land. In fact, most of the creeks in Murrells Inlet don't drain land. They drain salt marshes. And those creeks also are first order and sometimes second order, but you rarely have a third order creek that just drains salt marshes. And they function a little differently. So all of a sudden, you're beginning to get the messages about tidal creeks. Spatial complexity is very big. They're very different. And they all perform different functions, but they're linked, and it's not a demarcation line. There's some line that says, this is first order, this is second order, this is third order. It's a transition. It's a continuum that occurs from the land to the mouth of your inlet out there. But you have to understand that process if you want to regulate, manage, or look at how it affects humans.
And is that true, Fred, going up into the watershed a considerable distance from these marsh creeks? That you have to understand the entire system? Because we hear so much about the pollutants that run off rooftops, sidewalks, driveways, those things.
I'm going to let Denise answer that question, but I want to make a comment before she does. You have to remember, when you get a creek and particulate material, stuff that is associated with particles, most of them might be sediment particles, they're going to settle out fairly quickly. And so most of those are going to get caught in that headwater creek. And we looked at about 50 creeks from Cape Fear to somewhere in Mississippi. Alabama, actually, wasn't it? And we looked at a wide range of creeks. That first order creek is where most of the bad chemical stuff gets trapped. And Denise's dissertation was on what does it mean and how does it happen?
So if we're talking about looking at, is that on again?
It's on.
Okay. When you're thinking about creeks that actually drain upland, right, and those really headwaters, the material is, and the pollutants end up being the highest at the very upper reach to it. When you talk about a salt marsh creek, like Fred was pointing out, where you have just salt marsh surrounding it, actually we find the highest contaminant levels at the bottom of that creek, right, where it enters into a larger system, because the pollutants are coming up that system, not down it. So there can be very different distributions of contaminant levels in salt marsh creeks compared to upland draining creeks.
Okay. But what are some of the effects on the marsh of an increasingly impervious watershed? Denise said that in your casual survey that about 24% of the Murrells Inlet watershed appeared to you to be impervious, or in other words, paved or roofed or something like that, hard surface runoff. So, you know, what signs in the marsh indicate that it's a compromised or degraded watershed? And how would you characterize Murrells Inlet in these terms?
So Fred and I came to South Carolina in 1994 and started working with Fred. So we've been working together for 30 years. And we've studied 50 tidal creeks throughout the Southeast and the Gulf of Mexico. And what we found was that as impervious cover increases, and it's about above 10 to 30%, is when we start to see changes in the tidal creek. And so we typically focus in the tidal creek specifically because that is sort of the conduit of the water, right? It all ends up in that creek after it drains off the marsh. And so we have found increased pollutants, including your fecal coliforms in the water. PAHs, those fossil fuels, increase as development increases in the surrounding creek. We find changes in the biological community in that creek, particularly Fred and I are benthic ecologists, and so we really are interested in the animals living in the mud, those worms, small crustaceans. And so you actually do see a shift in that community. What am I missing?
Well, our pollution-tolerant organisms that live in the mud increase as you increase impervious cover. When you get above 30%, you've got a lot of them. In fact, you got almost all, that's almost all that's there. Pollution-sensitive species decline. And doesn't necessarily, however, mean that the less food for fish. They're just a different type of food, and crabs and whatever. It's just less. The water quality declines in terms of, at low tide, many of these creeks have pretty low dissolved oxygen, especially at slack tide. But they're getting a lot of nutrients from the land. I guess the thing that most starts to concern people is, can I eat the seafood and can I swim in the water? And I rarely have been in a creek anywhere from Cape Fear to Mississippi where you've got 25% impervious, which is what I would call a suburban, almost an urban environment, that you meet swimming or seafood eating standards. And we've looked at a lot of them.
And it's a good time to point out here that, as I understand it, 1/3 of Murrells Inlet's shellfish beds, recreational and commercial, are closed at present. I think that's right. If anybody knows that's not right, please correct me. So we are seeing such a decline in the shellfish of the creek. What kind of measures can be taken in a situation to reclaim or restore a compromised or degraded watershed? I mean, is reclamation even possible? Are you guys aware of any place where such efforts are being undertaken and how they're going?
So it's really hard once you pave something, right, to get the pavement removed. However, right, it's all about as many things as we can do. You know, it's like the concept of death by 1,000 cuts, right? Now we're talking the opposite. We've got to do everything we can to get more water into the ground. So I recently, my driveway was essentially caving in, and so I spent more money, but I put in impervious pavers. So that my exceptionally long driveway, now I get tremendous joy out of watching it rain and nothing leaves my driveway, right? And so, you know, again, I had that opportunity, and so I took that and practiced what I preach. But it really comes down to, right, we gotta get our pollutant loads down. So, you know, pooper scooper programs, anything that's going to paying attention to when you apply fertilizer, Anything that's gonna reduce pollutant loads is a good thing. And then we wanna get more water into the ground. So either from in future developments, right, trying to encourage the county or this town to actually implement stricter regulations about having more pervious surfaces, trying to use rain gardens. I mean, there's a whole host of different measures that can be taken to try to reduce the volume, that stormwater runoff, plus the actual concentration in that pollutant load.
I guess I'm gonna throw a little, I don't know what on the story, but the story is, I don't know of a creek that's ever been restored, a tidal creek. Or we have a lot of success with restoring intermittent or ephemeral streams in freshwater environments. We can put the sinuosity, the curviness of the creek back in. You can do things that decrease the flow. You can do things to keep water up on the watershed, or help it sink in faster. And it works in freshwater environments. You can manage it. We're trying, they're still fighting it, to restore Gadsden Creek in Charleston. They don't have a prayer. It's not gonna happen. It's just, you're trying to restore where the city dumped its waste for 50 years. There is no creek bed. There is no topography. There is no pattern. And you have to restore a creek, you're gonna have to reduce the volume and flow of fresh water back to some natural state. And you're gonna have to restore the topography of the creek, and you're gonna then have to worry about it. I don't think it's going to happen, or it's not gonna happen quickly if it does. I'll take Chesapeake Bay, where I spent a large part of my career working on. We started restoration in 1970. And what was the indication that we had a problem? Seagrasses were going. We had a big dead zone from low oxygen out in the main bay. And guess what? It is now, how 70 to now is 50 years. We're beginning to see pretty good recovery on the seagrasses, and some of the dead zone is going to go away. Some of it's gone away. So that's 50 years and we knew what the problem was there. The problem in Chesapeake Bay was nitrogen coming down from agricultural lands in Pennsylvania, Maryland, and Virginia. And it's taken that long to see that. I gave Chip an article. I gave my standard Tidal Creek talk in Bluffton for 20 years. I mean, more than 20 years ago, 30 years ago. And I thought nobody listened. I talked to county council there so many times that I never saw the same faces on county council twice. I thought they changed county council people like I changed t-shirts. And I said so one time. I didn't think anybody listened. I gave Chip an article that came out in the Bluffstonian, which is the newspaper for the town of Bluffton. And it was the ghost of the estuary, what Fred Holland told us. And about the May River, what was going to happen. Well, it happened. And they did listen. They developed the stormwater plan. And it is the best plan I have ever seen. It worked. They have began to push it back. It involves in using these technologies to get the water back in the ground. It uses technologies, including a lot of ponds, which I'm not the biggest favor of, but they do reduce the volume and flow of a particular event. And they do capture some of the stuff that's coming down in those stormwater ponds. You hold it, you have to dredge them, and you have to dispose of it in some way, but it does protect your creek to some degree. So if you want to find out something that's been successful, look at the Bluffton Stormwater Management Plan. It is excellent.
Chip, if I could, on that point.
Yeah.
We have studied the daylights out of the work they've done in Beaufort and Bluffton and reached the same conclusion you have. They've used their research, they've had total support, it seems, from their county government. They've had a team of experts that have been working on it. They got over, I think, $2.5 million in grants. And we gave a chart comparing what they've done in Bluffton to what we've done in Georgetown County, and the county government rejected it. They denied it, and we've spent zero on improving. So we agree with you. That's an outstanding example to go by, but they won't listen. They absolutely won't. We've spent $0 complying with our stormwater permit and improving the water quality in Murrells Inlet. The county government has.
Well, I haven't gotten to one part of the story which I've sort of avoided. The human impacts of screwing up the volume and rate of inflow. It comes down in the end to an issue that I think is important, and that's flooding. And that was one of their problems. They had a flooding issue, among other things. The second part of that, though, is if you don't do something, it isn't going to be like it is now. It's going to be pretty miserable. You're not going to have shellfish. You're not going to be able to swim in the water. There's some places I took graduate students, with what I know now, I put Denise in some places. I put her in some Superfund sites, not knowing they were Superfund sites, walking around in a pair of pants and a t-shirt, taking sediment samples with me, and they, 2 or 3 years later, they come in and dredge out all that stuff. And she's not had any children yet. I was kind of worried. I didn't worry about it then. I was young and I was dumb. But it will become a place that it won't be fit for human swimming and eating of seafood. And that usually changes it. But you also get a chance to vote.
True. Fred, is there one particular thing that we as individuals or we as a governmental polity could do to forestall that dire result that you talk about? What's the most important thing to do?
Most important thing to do is, there's this book, there's the Model Stormwater Ordinance by the South Carolina Environmental Law Project, Amy Armstrong, right down the road in Pawleys Island. It's online. Get Georgetown County or whoever needs to pass it. Second thing is vote. The third thing, there must be something like a river keeper around. If you don't have one, get one.
Well, we're all coming out Sunday to pick up all the trash in the inlet, but that's the trash, and it's a visible thing, a good thing. That's not going to save the watershed. But you guys have been tremendously informative, and we thank you so much for coming and enlightening us on the challenges ahead. Thank you.
I had 2 healthy children. They're going off to college.
Okay. So don't worry. Good.
And we're going to take just a minute. Kelly, would you come up and tell us just briefly about our marsh counts and give us a little cheerleading for Springtide on Sunday? Fred and Denise, Dennis, thank you so much. Very informative. Kelly's the senior manager of conservation at the South Carolina Aquarium, and she works across the state to help communities use citizen science as a mitigation tool to inform solutions to plastic pollution. She's the principal investigator for Our Marsh Counts, a 3-year collaborative project aiming to improve estuary health in Murrells Inlet. In addition to providing insight into Murrells Inlet litter data, tonight, this Sunday, Kelly will be engaging with volunteers to help gather data on marine litter at Springtide, an event at which both she and the Our Marsh Counts program have become an integral part.
Thank you, Chip, and thank you all for sticking around. I know a few people are drifting off, but we did an Our Marsh Counts Creek talk last year, and I don't know how many of you were here, so I'm gonna just give a really brief overview of what the project is. It is a coalition project, so we have a coalition of partners here in Murrells Inlet, Coastal Carolina University, and then the South Carolina Aquarium in Charleston. working in Murrells Inlet to reduce plastic pollution. This is a NOAA Marine Debris Grant, and it's a pass-through grant through Sea Grant. So we have a Sea Grant representative that is that is part of our coalition. Sandra and I worked very hard for multiple grant proposals to try to get funds to do this work, and we finally did get awarded this NOAA Marine Debris Grant in fall of 2024. At the core, so the South Carolina Aquarium, we have a conservation program working on plastic pollution. We work throughout the state. And we, as Chip mentioned earlier, we take litter data during cleanups. And when I say we, I mean you. Well, like everybody who's picking up litter, we are hoping will collect data. So why data is so important, if you just pick up trash every day, or once a week, or once a month, the trash shows right back up, right back up, right back up, right? If you collect data, you can start looking for the sources of those debris, and then you can have conversations with businesses or whoever you need, or your policymakers, local policymakers, about where the debris are coming from and how to stop it. You can't do that. You can't have those solutions-based conversations if you don't know what you're finding. And we've been doing this work since 2016. 2017 is when we kicked off the Litter Journal, and we have seen litter data be part of many, many solutions over almost 10 years, including policy. A lot of the single-use plastic bans in South Carolina, 14 of the 19 litter data were used to help inform those bans. 2 smoking bans on local area beaches in Charleston would never have passed without litter data, cigarette smoking data. Isle of Palms, working for a year from 2018 to 2019 in about a 4-block area, once a week in the summer, once a month in the off season. 25,000 cigarette butts were recovered. So you can say there are a lot of cigarette butts. We picked up a lot, right? But when you have hard numbers, real numbers, that it speaks volumes, and I can safely say that those bans would not have passed without this really important data. Now, it sounds like data, we have to take data, like that sounds like a drag to many. But there are natural data collectors among us all. And so you work in small groups, there's 1 data collector and 2, maybe 3 folks that are picking up. And it works, you guys. It's really fun and engaging, and you communicate more, and it's really fun. So I just want to encourage you all, 1, come out to Springtide on Sunday if you can. We will be there, our Marsh Counts will be there with clipboards to get into your groups and collect data. It's really important. We have been doing this now at Springtide since 2022. That was our first time. And we've been working in Murrells Inlet to do data collection for a while. And on the back of this sheet, I have some data, a data analysis of basically 2022 through 2025, so 4 full years. And year over year, about halfway down in that table, year over year, this is a very different debris analysis than we see in other municipalities all over the state. Cigarettes are always first, without a doubt, but plastic straws are second every single year, year over year, and that is not typical. And so we know we have a plastic straw problem here in Murrells Inlet, and but you know, 77% of all debris picked up is plastic. That's a big problem. You guys were talking about watersheds. Plastic pollution is getting swept from land into ditches and into storm drains, and it's getting out into not only our waterways, but into our oysters. It's breaking down into microplastics. It's getting into oyster shrimp. There are studies that that's happening. It's in our bodies. We have to understand that human health and environmental health are intrinsically linked, and we cannot just be okay with plastics being rampant everywhere we go. And we can't be okay with being handed plastics in every restaurant, in every grocery store, in every quick Circle K. I mean, we have to do more. So that's what we're here to do with our marsh counts, reduce plastic pollution. We're doing it, we're making the case with litter data, how these things are leaking out into the natural environment. But then our big priorities this year, one of our biggest lifts this year is creating an inlet-friendly business program. And this was an action that was identified in the 2014 watershed plan, Murrells Inlet watershed plan, to create this inlet-friendly business program. And we are attempting to do that with a little more focus on plastic, some focus on stormwater actions, but reducing plastic. Styrofoam is really common here. I don't live here, but almost every time I go into a Murrells Inlet place, I get a styrofoam cup or a styrofoam to-go box, and you guys, it's toxic. It's literally a carcinogen. You don't want your hot food or your food in general in styrofoam. So you need to make your voices heard and say, I can't take this as a to-go box or drink. Styrofoam, plastic straw, so this inlet-friendly business program will reduce the amount of plastics you receive when you go to businesses that are certified as inlet-friendly. Now, what we need there's data on one side, hopefully everyone has one. On the second side, it has all of our priorities. I just talked about the inlet-friendly business program. But there is a community survey right in the middle with a QR code. We need everyone possible to take this survey. It's only 5 questions about your thoughts about sustainability in the inlet. We're hoping those survey results will give us kind of the oomph we need to convince local businesses, business managers and business owners that people, their customers, want more sustainability in the businesses. So we need you to answer the survey so we have that information to provide to business owners and business managers. So please, 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 if you do nothing else with our marsh counts, please take this survey and join us on Spring Tide. So a couple things out here. Since you're all going to take a survey, you're welcome to take either a canvas bag or a reusable water bottle. And we trust that you're going to take the survey if you take one of those. There's also, so you can join the group cleanups and collect data as a group, but I have some solo sweep kits. If you pick up trash ever, we want you to take data. And so there are clipboards with a couple of data sheets. You can make copies and information on how to do a solo sweep, and a little mesh plastic bag. It's plastic, but it's reusable. You can use it for 20 years, right? I mean, it'll last for a very long time. That's the good thing about plastic. We're not trying to vilify plastic as a material. It's okay when it's built from something that's meant to last for a very long time. It's the single-use stuff that's used once and thrown away. That's the problem. So anyways, grab a solo sweep kit. I think there are 5 or 6 out there if you would like to contribute litter data to the Litter Journal and help us with this project. I think that's it. Thank you, guys. Thank you, Chip.
Thank you, Kelly. Well, we've all got a lot to do, and I would like to ask you, ma'am, to stand up and show us all that poster that you so kindly brought in. I think we all need to get a look at that.
Well, I'll have to tell you a story about my daddy. He wrote my mom a love letter from North Africa in World War II. And he said if he ever made it back alive, he was gonna, buy that little piece of paradise down at Murrells Inlet. And my daddy made it back alive. And he bought the piece of property for $2,000. And it's at the, I think everybody knows where Beaver Bar is. Well, it's down that road on Jordan Landing Cove where Mickey Spillane's house is at the end of the road. Well, Georgetown County is not good about informing people that live here what's gonna occur. I lived in Mount Pleasant for many years, and they always had big signs that said, you know, they were gonna rezone the area. Well, it is lot development. I bet y'all don't even know where that is, do you? It's off of Stanley Avenue at the very end by the fire station, but you gotta go to the very end. Well, lot development, they went to the council and nobody knew about the rezoning. I mean, because this is across the creek from where I live. Let me show you where. So this is the best picture right here. These on this side. Okay. Nobody on our street did not even know that it was going to be rezoned. And they took down the brick home that had been there, because my daddy bought the property in 1947, and Hugo took the first house, and when I started seeing all these trees come down, I mean, you couldn't even see behind this property. Well, by the time they finished, on this side it shows they had to have taken down about 50 trees, and now there's only like 6 trees left, and they are building 3 homes on this one piece of property, which is not a big piece of property, and they're going to try to sell them for like $2 million. Well, what has concerned me is, if you look back over on this side, they had approved the pier and then a floating dock, but it wasn't going anywhere. It's going to be near this concrete seawall, I call it. But after they got that approved, you know what they're doing now? I'm just so upset. On our little creek, which is Rum Gully Creek right here, which has no water, none at low tide. So the lot development is trying to get approved 3 piers coming across this beautiful marsh, and it has a bunch of oysters. So they're trying to get 3 piers going across that beautiful marsh and oyster beds and come out into our creek. I mean, if they do this, we won't be able to get out of the creek. There's not enough room.
And this is, I'm sorry to interrupt, and I applaud you for your efforts on that. This is one good reason why anybody who lives along a creek, who doesn't know all of your neighbors, it's a good idea for everybody on the creek, both sides of the creek, to get everybody else's phone number and not start like a HOA where you're trying to tell on each other or anything like that, but just so that you're all aware. I'm aware of the lot development that you're talking about, and, you know, I mean, to y'all, it's obviously it's a tragedy going up at the end of your creek, I know it is. But one way for neighbors to help neighbors is for every neighbor on a given creek to know what's going on that creek.
Yeah.
And you've got an uphill fight. I just want to, all of us give you a hand for taking it in there.
We, all got together and we had to write comments on each. They wouldn't let us just write one,
Right.
but each of the piers, floating docks that are coming out. So we sent a lot of, comments
Oh,
about.
I'm sure. I know all of you guys are up in arms. A friend of mine over here, Captain Conrad, is a neighbor of yours.
Oh, yeah.
Ladies and gentlemen, we've got to break it up, but I want to thank you all so much for coming, and I hope you got something out of this. I know I did, and we'll be looking for you Sunday morning.